Here's paper B, paper 2. Okay, so Alistair buys an antique chair for $450, expect to increase value at the rate of 6.3% each year. How much is it expected to be worth in 4 years? Okay, so it's in the future, we're just calculating the percentage change over the next 4 years, but it's going to compound because that 100% will be changing every year. So we're starting with 450, so our calculation will start with 450. I'm multiplying it. Well, for 6.3%, that'll make it 106.3% because it will be increasing in value as it says in the question, which is 1.063 as a decimal. Okay, remember there's a 0 there, there'll have to be a 0 here. Okay, that 0 is not going to go missing. Now it's 4 years, so we're going to cube that. Okay, and that gives us the answer 540.5206 and so on. Because it will be money, it has to be cut off at 2 decimal places, so it's going to be £540.52. Okay, so in there, 1 mark for your 1.063, 1 mark for your power 4, and 1 mark for your answer. Okay, question 2, we've got a standard deviation again. Okay, so I'm going to do it here this time. Part A, we're looking for the mean first of all. So that's 12, add 14, add everything else there up to the 3, divided by how many there are, so it's 3, 7. Okay, doc. Okay, and that works out to be 9. Okay, okay, so that works out to be 9. So our standard deviation, we know we need 2 different columns. We need our x's and we need our x squareds. Okay, so we've got 12, 14, 10, 9, 4, 11, and 3. Okay, that's our x's. And we know at the bottom we need the total of the x's, so that's 63. Okay, then we do our x squares, which is 144, 196, 100, 81, 16, 121, and 9. Obviously, yours will be a little bit neater than 9 there. Okay, okay, again by magic here she is. Okay, so we've got our total of the x squared is 667. Then we've got our total of the x's, which is 63 squared, all over 7, because that's n, and then all over 6, because that's take away 1, and then typing that in your calculator, you're going to get an answer 4.08248, and so on. Which is 4.0823 significant figure. So there's your standard deviation. Now for part B, make 2 valid comparisons about the performance of the team under the new coach. So in the old coach, right, sorry, I had to pause there. So I'm going to just start B again. So make 2 valid comparisons about the performance of the team under the new coach. Okay, so we know here the mean was 9 for the old coach and 4.08 for the standard deviation, and the new manager produces a mean of 10 and a standard deviation of 2.48. Okay, so we're talking about the goals in a tournament. Okay, so goals in a tournament. So make our statements. So under the new coach, okay, there is a higher mean. Okay, now you have to say what that actually tells us as well. Okay, so the team on average scores more goals under new coach. Under new coach. Okay, so that's your first point. Your second comparison with standard deviations will start with your fact again. Standard deviation is lower under new coach. Therefore, number of goals is less varied. Is less varied in the tournaments. Okay, so remember, standard deviation measures how spread out they are. Okay, so the fact that there's a lower standard deviation means that it's more consistent, it's less variation. Okay, so let's look at marks. 1 mark for the mean, second mark for having the two totals correct for your x and x squared, third mark for your substitution, fourth mark for your standard deviation, and 1 mark for each of your explanations. Okay, question 3 here. The diagram shows a cuboid, blah, blah, blah. P is a point that, Q and U, M is the midpoint of OR, and N is a point in UQ such that UN, so that bit at the top is a quarter of the whole thing. State the coordinates of M and N. Okay, so M, remember, 3 vectors X, Y, and Z. That's how far along it goes. Well, for M, it's not going along any. Going back, it's going half of the way back because it's the midpoint of that line. So the whole thing from here, I know, goes back 6. So for M, it's going to go back 3. And the point is not going any up in there. So 0, 3, 0. Okay, that's 0, not 6. Okay, for N, it's here. It's going to be 8 across. It's going to be all the way back, so all 6 back. And then it's a quarter at the top, so that's 3/4 of the way up. So that's 4, so 3/4 of 4 is just 3. Okay, and that's just a mark for each. 1, 2. Equation of a straight line. Okay, you've got 2 options to the equation of a straight line. You've got y equals mx plus c, and you've got y minus b equals m brackets x minus a. Okay, now you want to use y equals mx plus c if you've got the y-intercept, which I don't have here. So I'm going to use y minus b equals mx minus a. I know that's what I'm going to use, so let's just write it down. Okay, now for that, I need the gradient and I need a point. Okay, now I've got a point, I'm probably going to use 2, 5. Okay, because it's got no negatives. Okay, so that's, I'm definitely going to be using that. Okay, now I need to find the gradient. Now I've got 2 points, so to find my gradient, I can just use my gradient formula. y2 minus y1 over x2 minus x1. Go to my points. Okay, that's an x, that's a y, that's an x, that's a y. This is 1s, this is 2s. Okay, so that's 5 minus minus 3. Careful your negatives there. 2 minus minus 2. Okay, I'm just going to come over here. I know it's not neatest. 5 subtract negative 3 is 8. 2 subtract negative 3 is 4. So 8 divided by 4 is 2, which I can use in my formula. So this is my gradient, that's AB. So it's y minus b, which is minus 5. Gradient is 2, x minus a, which is 2. And let's simplify this. So y minus 5, break out my brackets here, is 2x minus 4. And add 5 to both sides gives me 1. Okay, bad question because the y-intercept should be filled in there. No mistakes. Okay, so 1 for knowing how to find the gradient, 1 for calculating the gradient, 1 for the substituting into that formula correctly, and then 1 for the simplification at the end. Okay, a spiral staircase has been designed. We've got a sect of a circle, the radius 1.4, angles 4.6. For the stairs to pass safety regulations, the arc. Okay, so I'm talking about arc. Must be at least that. Will the staircase pass safety regulations? So we need to know what the arc length is, and then we need to compare it to a 0.8. So formula, which we do not get in a formula sheet, is well, the fraction of the circle we have multiplied by the entire circumference, because that arc length is a little bit in the circumference. This is a little bit, and that's the circumference. Okay, so it's 46 degrees out of a total of 460, blah, 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 46 degrees out of a total of 360. And I want that fraction of the circumference, which is pi times the diameter. Now, that's just the radius, so it's going to be pi times 2.8. Okay, so go to your calculator, type it in. Okay, which gives us the answer 1.1239, so on. Let's take it to 3 sig figs, 1.12 meters. Okay, now let's make sure we've answered the question. Will the staircase pass safety regulations? Yes. This stairway will pass safety regulations. And remember, in our answers, we always want a comparison as 1.12 is bigger than the 0.8 meters required. Exclamation mark to show that you're excited. Okay, so one for subbing in, one for answer, one for your comparison, and you may also get a mark for that formula, but it varies. Okay, question 6, we're looking at volume. Okay, so we're in a volume of the water here. Okay, so a volume in the shaded bit, and I hope you can see there that this shaded bit is going to be this whole cone without the cone at the top. So we want the volume of the big cone, let's call it volume large, which we know from our volume sheet is a third pi r squared h. Always check it, you don't want to lose stupid marks like that. You can help it, which is pi, the big cone has a radius of 12.5. So we're going to square that, and the height is 18. Okay, so 1/3 times pi times 12.5 squared times 18. Okay, 2945.243 and so on. And then we want to find the bit that's missing from the top. So let's do the volume that's small. It's still going to be a third pi r squared h. Okay, which is a third multiplied by pi. Now the radius there is 6, so it's times 6 squared. And the height, well, if the whole thing's 18 and the bit there is 14, the height of the small cone is going to be 4. Be careful with that. Don't just jump in and use 14 because it's the other number. Okay, so we'll go back to our calculator. 6 squared times 4 at the end this time, which is 150.796 and so on. So the volume total for the answer is 2945.243 subtract 150.796. Which gives us the answer 2794.446 and so on. We want an answer to two significant figures, so that's 2 there and the 9 will round it up, so 28. Remember your zeros to keep the size and all the same, and it's centimeters cubed. Make sure you've got that, and you may lose marks if you don't have something, and you don't want to do all the hard work and miss out a mark because of something daft. So 1 mark for subbing, second mark there, third, fourth, 1 for subtracting, and then 1 for your sig figs at the end. So it's a lovely 6-mark question to pick up on. Okay, 7. Full summer holiday is this. That includes a 5%. What would it be without it? Okay, so this number here includes the 5% booking fee. So that's not 100%. We're looking to find 100% because we want it without that 5%. Now your first bit is a trick here. That £892.50, that is 105%. Okay, we need to go back down to come back up to what the original 100% was. So to go from 105 to 1%, we're dividing by 105, and then to go from 1 to 100, it's times by 100. Okay, which gives us £8.50 for the 1%, which means that 100% is £850. Okay, nice and easy. Mark this one. 1 mark, 2 mark, 3 mark, 1 for each stage. Okay, that first bit is the most important. You don't get that, you don't get it. Okay, question 8, starting to get a little bit more involved. Okay, there's a heavy beam, blah, 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 small triangle, and we're looking for the length of cable CB. Okay, so we're looking for C2B. Okay, now, notice in that big triangle, I've got 9 and 26. I've got one of my loops there. Okay, so I've got one of my loops around here. Okay, so if I have, I'm looking for this side, if I can get this angle, that would be lovely. Okay, and look, 62 degrees there, that's a straight line along the bottom. So this has got to be 118 degrees to make that straight line up to 180. And then there you go, there's a second loop. And because I've got the two pairs of side and opposite angle, I know that I can use my sine rule. Okay, so let's go formula sheet, check sine rule. Okay, you don't need to use it with that. Remember, we only use this as a wee indication. The small letters are on the top. So that means our sides go on the top in our pairs. So we're going to have x over sine 118 over 9, because that's the side, over sine of the angle, which is sine 26. Then we cross multiply, boom, boom. So x sine 26 is equal to 9 sine 118. And then we need to get rid of a times by sine 26. So it's 9 sine 118 over sine 26. Okay, go to your calculator. Okay, which is x equals 18.127, so on. Let's do 3 sig figs. 18.1 meters. Okay, marking, you've got a mark for that 118. Okay, I would encourage you just doing the diagram, that's going to pick it up. Okay, a second mark for using the sign properly, third mark for rearranging, and a fourth mark for your answer there at the end. Okay, maybe a fifth mark in there for knowing how to use the sign rule, but that would be quite generous, but I've seen it happen. Okay, 9. Oh, brilliant. Straight away, it's telling us the type of question. Mathematically similar. We know we're using similarity, which means we know we're using our scale factor. Okay, so the height of the smaller bead is that, and its area is 0.9 meters squared, square centimeters. The height of the larger bead is 2.4. Find the area. So we're looking for area. Similarity means we're getting the scale factor. So the area of the larger one. Well, a scale factor, I know if I'm making it bigger, I want the bigger number on top. I'm doing the area, so I need to square that scale factor because area gets bigger in two different dimensions. And I'm multiplying that by the smaller area, which is 0.9. Okay, so again, calculator. Which is 14.4. So the area of the larger is 14.4 centimeters squared because it's the area. 1 for your scale factor, 1 for knowing to square your scale factor, and 1 for multiplying it through. Okay. So here's a rhombus. Side of each rhombus is 50 centimeters long. The obtuse angle is that. Sine area of one paving stone. Okay, so we're looking for the area. It's going to be a bit tricky here. We've not really done area rhombus this year. But what we have done is the area of the triangle. So if I put in that line there, the rhombus is just like a square. It's like a drunk square. It's just a square that's fallen over. So they're all 50 centimeters. And there's a line of symmetry in the middle there. So if I can find the area of that triangle, I can double it to get the area of the rhombus. So the area of the triangle, formula sheet, half AB sine C. Remember, it's like the cosine. We only need the two sides and the angle in between. So it's a half multiplied by the two sides. Okay. Okay, which is 46.359 and so on. So the area of the rhombus equals 2 times the area of the triangle. Okay, we're doubling that because we've got both sides. So 2 times 46.359. Keeping your calculator, just multiply by 2 to keep your accuracy. Okay, so that's 92.718, so on. I know 7 figures, so I'm just going to do 3, so 92.7 centimeters squared. Okay, so one for using the area of the triangle, the correct substitution, one for following it through to the answer, one for knowing to multiplying by 2, and then one for a good answer. Oh, I went the wrong way. Okay, 11. Okay, we'll get trig functions in there. Okay, a nice wee overlap. So we're doing f of 270, which means we're doing what is 270 on the graph 4 sine x. So what is 4 sine 270? Couple of ways of doing it. Okay, you can either draw the graph, okay, which we know a sine graph that's got a 4 in front is going to be like that, at 4 and minus 4. And there's no movement in the middle, so there's only one wave in 360. So 270 is here. So that's going to be at minus 4, okay, which is minus 4. The other option is to calculate sine 270 on a normal sine graph, which is just minus 1 and then times it by 4. Okay, so B, we're looking for when f of t is equal to 0.8. Now f of t is going to be the same as f of x, except rather than having the x at the end, it's got the t at the end. So again, we're solving a trig equation, and like it tells us, we're looking for two possible values. We get two values from our cast diagram. So the first thing we're going to do is get rid of this 4. So divide by 4, sine 2 is going to be equal to 0. Sine t is going to be equal to 0.2. And we're in our cast diagram. We're talking about sine, we're talking about a positive. So it's positive there and there. Let's get an angle. Inverse sine of 0.2. So I change back to black, but I'm running with it now. Okay, which is 11.5. Okay, so our answers, our x's, or in this case our t's, from that first quadrant is just a, and the second quadrant is 180 minus a. Okay, so it's 11.5 degrees, and it is 168.5 degrees. Okay, there's your values for t. Okay, so your first mark there will be saying 4 sine t equals 0.88. Being able to interpret that question is definitely worth a mark. Second mark for dividing by 4 and getting 0.2. Third mark for 11.5. Fourth mark for 168.5. Okay, these are our favourites. So like we've got a circle and we've got a chord in it. Okay, so in there we can create a right angle triangle. You know it's going to be something about that. So let's create our right angle triangle. What information do we have? We'll get the radius is 1.4, so let's find any radiuses. Okay, so there's a radius, O to A, that's got to be 1.4. Okay, also from O, the right thing at the bottom we know is 1.4. And the width of the surface from A to B is 2, so that right angle triangle there is just going to be 1. Okay, so in that right angle triangle, let's do a wee sketch of it elsewhere. 1.4 and 1. If we want to find, let's just call that x, just in a right angle triangle, make sure you put that right angle in. X squared is going to be 1.4 squared minus 1 squared. So x is the square root of the answer, which is the square root of 0.96, which is 0.9797, so on. Let's just call it 0.98. Oh, sorry. Press the button now. Messed up. Okay, let's call it 0.98. Okay, so we know this bit here is 0.98. Now you're looking for the depth of oil. Okay, so I'm just going to change into blue here. Now, from the center down to the bottom is a radius, so that's going to be 1.4. So the depth at the bottom, let's call it D, is going to be that whole radius, take away 0.98. Okay, whatever's left over is going to be in oil. So it's 0.42 meters. Okay. Now getting the triangle is definitely worth a mark there. second for using Pythagoras, a third for x, and then fourth for the depth. Okay, and last question here. We've got similar triangles again, okay, so we're going to be using corresponding sides. The scale factor is 2, so to go from there to there is all 2 times bigger. Okay, show that x squared minus ax plus 7 is equal to 0. Okay, so the scale factor is 2, so 5 times 2 is 10, that's good. But also that means that 4x times 2 is equal to 8x plus 7. Okay, so 2 times the PR, okay, and that's just a setup. You probably won't need to, you actually you don't need to do it, it's like 2 times this is equal to SU along the bottom. So 2 times 4x is equal to x squared plus 7. And look, we've got everything involved there. 2 times 4x is 8x, which is x squared plus 7. And then we subtract 8x from both sides, and we show that x squared minus 8x plus 7 is there. Okay, so that's part A. So given that QR is the shortest side of the triangle PQR, find the value of x. Okay, now we know that x squared minus 8x plus 7 is equal to 0. That's what we found out in part A. Now that's a quadratic equation. And if we can solve a quadratic equation by factorising, brilliant. So we've got x and x multiplying to a positive, so both the signs are the same. There's a negative there, so they must both be negative. And well, 7 ones are 7, no other options, and that gives us the 8. So x minus 7 equals 0, or x minus 1 equals 0. So x equals 7, or x equals 1. Now we've done our maths. This is all I'm asking you to do. Now we just need to check. So given that QR is the shortest side of the triangle, so 5 is the shortest side. So this 4x, it can't be less than 5. So here, say if that x was 1, 4 ones are 4. So that would be the shortest side, but it can't be because it tells us that QR is the shortest side. So that x there, and absolutely all it is, in fact, you should have both answers and then score that out and say x equals 7 as QR is shortest side. So just put in your reasoning as well, just be really clear. Okay, so you're getting a mark there for setting that up, and then 2 for showing working and getting through to the answer. 1 mark for factorising there, 1 mark for solving, and then 1 mark for chucking away an answer there again at the end and being really clear about it. Okay, so that's a skill particularly guys are going to hire that you're going to need to pick up. Okay, you may even get a mark in part B for knowing to solve, but I'm going to leave that there just now. Okay, that's us done. Cheers for listening, or cheers for using it if you did. Let me know if you need any more questions done, or I'll try and get the next couple of past papers done over the next couple of days. Okay, cheers guys.